And now we've got our basic cos graph. There is the equation for this. Y is equal to cos x. Okay, let's just investigate quickly. There we've got, I say it starts by, but it's just where x is 0. Then my y is 1. Where the sine graph looks different. The sine graph starts by 0, 0. Hey. So our cos graph starts there by 0 and 1. It cuts by 90, turns by 180, cuts by 270, and then turns by 360. What is the period of our cos graph? Well, it's also 360. It takes 360 degrees for the curve to complete itself before we start with the second curve. All right, let's do the same. Let's go change, first of all, to our A value. And same story. It is a vertical stretch. If that is 2, our maximum will be by 2, and our minimum will be by 2. It still cuts and starts in the same place. For our x values, that is. All right, what's going to happen when we make it negative? Same story. When we make that negative 1, instead of starting by the 0 and positive 1, it will now start by 0 and negative 1. All the values that were positive will now be negative. And all the value in the original that's negative will now be positive. It's important to have a good understanding of this. All right. Let's make our A1 again, and then let's change to the value when we add to our trig ratio, moving it up or down. If we make this 1, it moves that the whole graph as is moved 1 up. So instead of starting by 0 and 1, it now starts by 0 and 2. Our maximum is by 2 and our minimum is by 0. And then same story, if we move it down, if it's negative 2, then it means we moved it 2 down. So it's worth knowing where our basic normally starts, by 0 and 1. So then we can immediately see 1, 2, that it moved 2 down. Okay, now we're going to change to both those perimeters. And let's figure it out. So I'm going to remove that basic graph. And okay, so when we see something like that, we're like, okay, what is going on over there? Well, if we look at the fact that the middle of the graph is now there, the whole graph must have moved up with 1 unit. Then we're like, okay, yeah, definitely moved up with 1 unit. But then if it moved up with 1 unit, we know that our basic cos should be there because it normally starts by 0 and 1, right? So if it moved 1 up, it means surely that it should have been by 2. But why is it not by 2 now? If we look at the shape of the graph, we can see from the point 0, it didn't start by looking like that, where it's going up. It started looking like that. So our amplitude must be or our A value rather, the coefficient of cos x there must be a negative. It starts looking like that and not like that. I hope that makes sense what I'm trying to say there. And I hope that you can visualize this nicely, but it's always so helpful. Grade 10s, I find that I quickly go jot in this basic graph for myself, and then I compare it with that to see what's happening. The fact that I can see, okay, this one looks like this, and this one is like upside down, then it means that my amplitude must be negative. And then to find the A value, I take the maximum of 2 and I subtract the minimum of 0, and then I divide that by 2. And that gives me my negative 1 A value over there. And then how do we find that it moved up? What is the easiest way to find that it moves up? Well, the fact that we can see the middle of the graph is not where it normally is, there, where our x-axis is. This one moved up because the middle of the graph is now there. Okay, so this can get pretty tricky, but if we know our basic, we're actually good. So however you make sense of this, it's up to you, just as long as you sit with this until you figured it out. Let's look at our tan graph.